Yeah, welcome to my talk. I'm Antoine Danois. I'm an Android developer at Citymapper, and today I'm going to talk about architecture. To build an application or a house, it's really important, but what is that concretely? And yes, there is a pun intended in it. So why am I doing this talk? So first of all, I don't like architecture. It's definitely one thing that I almost hate to do. But at some point, I understood that it's something important. Like in my career, I want to grow and I want to start doing more and more things. So at some point, yeah, I said to myself, like, yeah, maybe I have to be interested about architecture at some point. Because, you know, like usually my lead or my senior in the team just do the architecture and I just do the same after him, and it's working well. But yeah, at some point I have to try to understand what it is to be less scared of it. And yeah, with this talk, I just want to show you that, yeah, maybe if you don't like architecture or you think you are not doing architecture, you already have some basics. And if you really have no basics, I hope my talk will help you trying to learn a few things about architecture. So first, a bit of history. In the 50s, we have started to see the coding, we have started to saw the first line of code, and it was in assembly. And it was non-structured programming, and it was looking like this. Then in the 60s, we have started to do more structured programming, and it's also the first time that we heard the comparison between software architecture and civil architecture. So yeah, civil architecture is like to build buildings, etc. And in the late 60s, we have started to imagine a principle of layer. So we started with just like one layer, one tier with just everything, the UI, the business logic, and the data storage. And then in the 70s, we have started to see more and more complex languages, like the C, for example. And yeah, it was more structured, and it was more easier to do more, like, yeah, to architect, like the way you do things, etc. Then in 79, it's the first time we heard the model view controller, MVC. So maybe it starts to ring some bells here. MVC, we see that quite often. And yeah, in the 80s, more and more complex languages like the C++. It's looking like this if you never saw C++ in your life. In the 80s, we have introduced another tier, another layer to separate the UI and all the business logic and the data storage. And then in the 90s, a third tier appeared. It was more about, one about the UI, and the second one about the business logic, and the third about the data storage. And yeah, again, more and more complex languages. In 96, the model view presenter, MVP, and then web services. In 2002, the solid principles were introduced. Maybe also it's ringing some bells. With the solid principle, it's something really known. In 2005, the model view model. In 2007, something really weird that I'm going to explain to you a bit later in this talk. And then the microservices, the clean architecture, etc. So you have a bit of the timeline of the software architecture. And why do we need architecture? So without that, it would be really simple. It would be a big ball of mud. We just put everything in the same bag. And at some point, if we want to change something or to touch something in the project, if we don't really know like what is linked to what, you know, so it can just break everything. So yeah, this is why we really need architecture. Like for example, at the beginning of civil architecture, we had pyramids. So pyramids, it's really easy to build, ish to build, by just like a simple shape, and you just put rocks on top of them, or top of the other, and then you have something, and inside, there is, like, if you remove one rock, maybe everything will fail. It's really hard to find your way in pyramids. You know, we are still finding stuff, you know. So, and then you can have now, we have now nice architectures with arches, and we can go inside buildings, etc. So it's kind of the same. So yeah, we really need architecture for that. And yeah, the motivations. Ah bah d'accord, c'est pour ça que je ne voyais pas. Parfait. So yeah, now a few examples of architectures. The first one, so it's like one of the simplest. It's a client-server architecture. So it's just a client, that can be a software or anything, talking to a server. And the client is dealing with the UI, and the server with the data, and the server is just sending the data to the client, and the client just deal with it. Here, it's the peer-to-peer architecture. So maybe you already know what is a peer-to-peer, and if yes, you probably already did download some movies illegally or something, you know. But with a peer-to-peer architecture, a peer is a client, but also a server. So it's like creating big nodes, web, and everything. So yeah, to communicate, it's great. Another architecture, it's not related to software architecture at all, but this is the Beffroi de Montrouge, and we are inside. And it's a geometrical architecture made by Henri Deco in 1933. And you see, it's not a big ball of mud. It's not like a simple pyramid. It's a nice building with shapes, etc. And we can go in it. There are several rooms, and if we want, we can do some work in one room, and the other one will not be touched, etc. So yeah, I just put that here to have a more visual example. This one is the layered pattern, the N tier. We call that N tier. So yeah, this one starts to be a tiny bit more complex. At the top, you have the first layer, which is the user interface, so all the UI that you see on screen. The third layer at the bottom, which is the data. If you are storing some data, or just making server requests, etc., you are doing that in this layer. And in between, in the second layer, you just have your application layer, all your business logic, etc. is going to be made here. This one, I think, is one of the famous architectures and that we have. But yeah, and this one, so yeah, the IEEE 1471-2000. This one, I don't know if anyone is using this one here. But it's the first formal standard of a software architecture. So you know, you can have like formal standard of everything. Like if you want to do a cup of tea, like about everything. And this is the first one about software architecture. So it's a kind of hard to understand. So if you want to understand it, just go to the Wikipedia page and read it. But yeah, it's like this one has been made like to really, because any kind of architecture anybody can do what they want. You know, they can change everything. With this one, you are not really allowed to touch it like that. Everybody have the same. Everybody using this one should have the same architecture. Next, we have maybe the architectures that we are using the most in our industry, the MVC. So with a model, view, and controller. So the view is dealing with the UI, so the text, the buttons, the things you see on screen. And with the MVC, so the controller, so it established a relation between the model and the view, and all the logic is in the controller. So in the model, you are going to have your data, the storage, you're doing the requests to the server, etc. And the controller is dealing with it, and the view is just showing the data. With MVP, the presenter handles the change of data, apply the logic, and just show what needs to be shown to the view. The MVI is kind of the same, but with intents. One, maybe the most used on the Android world, is the MVVM, with the view model in between to expose the data to the view and also to take care of the link between the view and the model. So all of those are a bit of the same, but not exactly. There is some caveats. And also, if some of you are more on the iOS world, you have the MVVMC, and the MVVMC is the same as the MVVM, obviously, but with a controller. So it seems to be something really specific to the iOS world, but the controller is helping to instantiate the view controller and the view models, present the view controllers that you want to show in your app, etc. So yeah, I haven't really seen that in the Android world, but yeah, maybe it will happen one day. And on Android, what do we have specifically on Android? We have something called app architecture. So it's a really good guide that has been made by the Android team, and it was announced in 2017. And it's just like, it's not like you have to do that to build your app, but it's a really good guide to tell you, like, it's better if you do this and that, etc. So as you can see, it's layered architecture, with at the top the UI layer, and in your UI layer you have your UI elements, your buttons, your text view, your list, that kind of things, and your state. So the state is where you put your data. It's not where you get the data, but where you put and then can use your data. The domain layer is something optional, but they recommend you to have it. And it's just helping to avoid code duplication, to improve the testability of your app. You need to separate more stuff if you want. But yeah, this one is not really mandatory. And then the data layer. The data layer is where you put your repositories or your data sources. Like, yeah, if you want, like I said previously, you want to get do a server request, or you have to get any kind of data. It's where you are going to put this. You are going to put your models as well inside it. And also, you have a few other stuff that is part of the app architecture. For example, the app entry point, the activities, or the app shortcut are part of the app architecture. So even if you are just launching an activity, you are doing a bit of architecture. So yeah, this is obviously part of the first layer. Also the app navigation, when you do a configuration change, when you rotate your screen, change your local, etc. It's something that your architecture need to, it's like, yeah, it's doing something with the architecture. The app links, also the fragment navigation components. All of that kind of stuff is helping you to build a really good architecture. Also the dependency injection, Dagger or Hilt. I'm not going to talk a lot about dependency injection, but it's really helpful to have your different layers communicating between them. For example, your repositories, if you want them to be used anywhere, it's really helpful, even if it can be a bit hard to understand at the beginning. And yeah, all the architecture components, for example, the view binding, the data binding, the view model, the live data are part of the architecture. And also the data layer with the data store. So if you don't know what the data store is like the shared preferences, but better, with like to use with coroutines, etc. And work manager to do like heavy stuff in a different thread, etc. So this is more part of data layer. So yeah, that was the Android app architecture stuff. So if you want to know more, the Android team have built a complete guide with everything in it that you need to know to build a good app. Also, there is some official courses about it. And then, so you have a QR code here on the top right corner. If you want, you are just going to see these same exact slides. But yeah, here I put some interesting things. I thought, for example, this talk about from Marcel Verheer. It's more on the iOS side and more like deeply about architecture. This one about architecture pattern. This other one, I found it really interesting because it's one of the first documents talking about software architecture, and it's really interesting to see how they are imagining and thinking of it. And the last link, it's awesome-architecture.com. I thought like this one is really interesting because you have a ton of resources about architecture, but also about a ton of other topics. So yeah, just feel free to have a look. And yeah, I hope this talk really made you less scared about architecture, that it's something that everybody can do as long as you spend a tiny bit of time trying to read some documentations and to read some papers, which personally I don't really like it, but it's kind of interesting. And yeah, if you have any question, we can talk about it later. I'm here until tomorrow. So yes, thank you.